Okay, let's dive into something really foundational today. The C programming language came out of the 70s, right? But it's this amazing kind of bridge, connects the raw hardware, the metal, with the higher level code people write. But the big question, our mission for you today, is why? Why is C still so incredibly important decades later?
Yeah, it's fascinating. And you almost can't talk about C without talking about UNIX. They sort of grew up together. Original UNIX is written in assembly,
Yeah.
and moving that between machines, forget it, a total nightmare.
Right, tied completely to the specific hardware.
Exactly. But then, 1973, UNIX v4 comes along, and they do something pretty radical. They rewrite the entire operating system in C.
The whole thing? Wow.
The whole thing. And that wasn't just some technical exercise. It made UNIX portable. Suddenly you could run it on different types of computers. That C UNIX link, it propelled C into the big leagues for system programming.
So C basically unlocked UNIX, let it run free. That's huge. It's amazing something from that era still resonates so much.
Yeah.
So what are C's lasting strengths? What's the secret?
Well, number one is probably just raw efficiency, speed. A C code runs incredibly fast because there's very little between it and the hardware. Minimal runtime overhead, we call it.
So every clock cycle counts.
Pretty much. That's why you see it in places where performance is absolutely critical. Think financial trading systems, aerospace, tiny embedded devices. Anywhere a tiny delay could be a big problem. And crucially, it's still incredibly portable. Write it once, compile it almost anywhere with, minimal changes.
That efficiency makes sense. But you also hear about its influence, right? Like C++, Java, they built on C. Those languages seem, well, maybe easier. They handle memory for you, things like that. Does C's direct control still hold up as the advantage?
Oh, absolutely. For certain jobs, it is the advantage. Yes, newer languages add layers, abstractions for convenience. Makes the developer's life easier in some ways. But C deliberately skips a lot of that. It gives you raw, direct control. You're talking almost straight to the machine. No hidden costs for features you might not even be using.
Okay, this brings up that common phrase, C is easy to learn but hard to master. How does that work? The syntax looks pretty simple.
It is simple, relatively speaking. That's the easy to learn part, good for understanding core concepts. But the hard to master bit, that comes from the power C gives you and the responsibility.
Responsibility, yeah.
Memory. C gives you direct control over memory allocation and deallocation. Pointers are the famous or maybe infamous example. You have to manually manage memory with functions like malloc and free.
Ah, right. So you have to clean up after yourself.
Precisely. It's like driving stick versus automatic. The automatic is easy, gets you there. The stick shift gives you way more control, connection to the engine. But you mess up, you stall, you grind the gears. C is the stick shift for memory. If you're not careful, you get memory leaks, dangling pointers, all sorts of nasty bugs. It forces you, really, to understand what's happening at a deeper system level.
Wow. So it's powerful, but demands discipline. Deep understanding required. Does that mean it's mainly for experts now? Or where do we actually find C running in our tech today? Is it everywhere or just niche stuff?
Oh, it's far from niche. It's kind of hidden, but it's everywhere. Foundational. Big chunks of operating systems, Windows, Linux, Mac OS, Android, still rely heavily on C.
Really? Even Android?
Yep. And think smaller. Those little microcontrollers in your smart thermostat, your car's engine control, medical devices, embedded systems, ton of C there, major databases. MySQL, PostgreSQL C is crucial for their performance. Even parts of your web browser, like Chromium or Firefox, have C components, and the compilers that turn other languages into machine code, often written in C.
So it's like this invisible scaffolding holding up so much of our digital world.
That's a great way to put it. It's the deliberate choice when you absolutely need that peak performance, that fine-grained control.
So comparing it, again, briefly to, say, Python or Java, they offer convenience.
Exactly. Python, Java, C++. They pile on abstractions, automatic memory management, lots of built-in features to boost developer speed. C strips that back. It says, you want raw speed, direct hardware access, minimal footprint. Here you go. But you're driving.
Yep.
It's the closest you get to the bare metal without actually writing assembly code.
Okay, wrapping this up then. What we've seen is C holds this really unique spot. It balances structured programming concepts with, well, almost raw machine power. It forces a deeper understanding, doesn't it?
It really does. And maybe that leaves a final thought for you, the listener. C's enduring presence. It's necessity right at the core of so many systems. What does that tell us? What does this ongoing need for raw power and explicit control right at the foundation suggest about the technology we depend on every single day? Is it just good design holding up, or maybe a hint at the fundamental complexities we're always building on top of? Something to think about.